Welcome everybody to today's webinar. Yes, large screen. This is what I wanted to see. So we're going to talk today about the best Python geospatial data visualization libraries, specifically for the large enterprise. And your presenters going to be me and Simon. Simon, pleasure to have you on board today.
Thank you for having me.
Sure thing. All right, so what we're going to do today is we're going to discuss different technology stacks suitable for a corporate use case scenario, and we're going to demo an analysis and visualization using a publicly available data set. A few logistics before we get started. This webinar is going to be recorded, so just in case you want to review that or maybe share with your colleagues, it's going to be available probably early next week along with the slides, and we'll also share the demo files on GitHub. And in case you have any questions, feel free to ask them, and we're going to answer your questions as we go. All right. So about today's webinar, what can you expect from this webinar? So we are going to focus on context. So understanding the big picture is what we're going to provide today. So this is not going to be a deep dive into geospatial library usage. This is going to be subject to forthcoming sessions in January and February next year. And the setup is going to be your local laptop in conjunction with Python, Jupyter Notebooks, Anaconda, leveraging on cloud infrastructure as a service and platform as a service, specifically Amazon AWS and T-Systems Data Science Workstation. DSWS stands for Data Science Workstation, and Simon's going to talk about that today later. All right, so we're talking on behalf of T-Systems. T-Systems is hosting this webinar. It's the Deutsche Telekom business customer subsidiary. And I think as of now, the company employs 37,000 people. Is that correct, Simon?
Yeah, around that number. That's correct. Yeah. A lot of people worldwide.
Yeah. And T-Systems is highly recognized across multiple industries, specifically in Europe and in German-speaking countries, in manufacturing and automotive and various other industries. And my partner in crime today is going to be Lars Simon Zehnder. So Simon, do you want to introduce yourself briefly?
Yeah, sure. Thank you. So I'm a senior manager data science at MCS. That stands for Managed Cloud Services. And we are offering platform as a service and big data. I'm in the area of data science for, I guess, around 12 years, building models, training models, and did my PhD research in the area of measuring informed trading on electronic stock markets.
Super. My name is Raphael. I'm the CEO of a small data science consultancy, and I prepared the demo for today with Arnold Utre, who is in charge of data science projects in our company. All right, so let's make a couple of assumptions about you, the audience. So a quick questions to those guys who are attending us live today. Can you please share in just one or two words what your current role is using the chat? And Simon, maybe you can pick up the comments that are coming in. So we are assuming that you are either a BI analyst or a data analyst. So spreadsheet tools such as, for example, Excel, or business applications such as SPSS, SAS, SAP, Oracle, Adobe, you name it. So one of those solutions is very likely familiar to you. And if you're a data scientist, then very likely you're working with Python, for example, in conjunction with Jupyter Notebooks and Anaconda. So we are assuming some basic familiarity with object-oriented programming languages and some experience working with Python and a basic grasp of libraries, especially the main libraries, which is Pandas and Matplotlib. So these are the two libraries that the geospatial libraries that we're going to discuss today are building upon. But just in case that you have never, ever in your life worked with programming, don't be scared. I personally, I'm coming from a marketing background, so I worked as a marketing manager in a corporate environment for 2.5 decades, and I taught myself the basics of Python in a relatively reasonable amount of time. So if you call Excel your home and you have never programmed, this is something that you can get there relatively easily. All right, and we're also assuming that you're eager to learn about working in a utility-grade setup. So with that, let me switch to the technology stack that we are going to discuss today. So first of all, obviously the geospatial libraries. There's quite a lot of them which are available specifically for Python. So we looked at a total of 13 different libraries, and the selection criteria which we find important for an enterprise setup are the following. First of all, the library needs to be easy to set up. Secondly, it must be a stable release, so it should not be an experimental release. It should be easily available both in pip and Anaconda, and there should be a sufficient amount of documentation and a big community behind it. And last but not least, it should test and run successfully on both IPython command line and Jupyter Notebook. For those of you guys who are familiar working with geospatial libraries, you might miss ArcPy, which is a library specifically for Esri data. And this is going to be subject of a separate webinar, because we believe that Arc package, ArcPy, is extremely important in the large enterprise space. But for now, we're going to focus on two libraries which we selected based on the criteria which I outlined before, and that is GeoPandas and Shapely. So these are both general purpose geospatial data analysis and visualization packages, and Shapely is for raster data types and GeoPandas for vectorized data types. And both are going to be used in conjunction. So they essentially play together hand in hand to provide data analytics and visualization solutions. And they're very easy to work with, and they're highly customizable for complex tasks. We did not select some of the familiar or very popular geospatial libraries such as Folium and Dask. As far as Folium goes, I personally like working with Folium because the quality of the visualizations, they're just super, and the maps are interactive. But the downside is that Folium was specifically designed for data visualization on Leaflet, which is a JavaScript library for mobile-friendly applications. So it's basically for displaying data, and it's not built with analyzing data in mind. And as far as Dask goes, which is a library for big data, geospatial analysis, and visualization, this library, we like it a lot, but to us, it looks like this library is not mature enough compared to GeoPandas and Shapely. All right, so let's talk about the cloud building block that you can leverage on. So we like this image a lot, and we use it when talking to our customers and partners of like playing with Lego bricks, because when you're working in a cloud infrastructure and utilizing the building blocks, is very much like putting together Lego bricks. So the Lego bricks that we're going to talk about today is AWS S3, and S3 stands for Simple Storage Service, and it provides object storage through a web service interface. Then AWS Athena is an interactive serverless query service to analyze data in Amazon S3 using standard SQL. And then there is Amazon QuickSight, which is a business intelligence, or in short, BI service. And last but not least, Anaconda, which is a data science platform for sharing packages, notebooks, projects, and environments. So what options do we have at hand in order to perform geospatial analysis? So we figured out there's a total of 4 different setups given the technology stack that we just presented. The first setup is you use AWS in conjunction with Athena being the querying service and QuickSight as the BI interface. The second setup is AWS S3 in conjunction with Athena. So in that case, Python is not required. The third setup is Amazon S3 in conjunction with Python. And in that case, you would run Anaconda Jupyter Notebooks locally on your laptop. And the fourth setup option is AWS S3 as your storage backup in conjunction with Python in a fully virtualized version on Amazon AWS. So that means that that your data would be co-located on Amazon along with your virtual desktop. So you can categorize those 4 setup options into 2 buckets. So the first one is BI low code. So this might resemble with you if you're coming from a BI analyst or data analyst background and you're familiar with spreadsheet tools. And the third and the fourth setups are, well, might be very appealing to those of you who feel comfortable working with Python. But like I said, beginning, it's if you are working with Excel, for example, as your preferred spreadsheet tool, then getting started with Python is not as difficult as it might seem. So we are going to focus on the third setup, which is Amazon S3 as the storage backup and backend, and Python locally on your laptop. So this is the technology stack or the preferred option that we are working with right now. Okay, so let me switch very briefly to my Amazon console. So Simon, is my screen still visible? I just want to make sure that everyone sees my screen.
I see everything. I'm excited to see what you do now.
Super. Well, as far as the cloud infrastructure goes, from our personal experience, it's very hassle-free because you don't need to take care of the underlying infrastructure. It's being by and large abstracted away, so you can just focus on doing your analytical work. And the problems, they really start when you have to set up your local environment on your laptop. So this is an image from one of my favorite shows, IT Crowd. And actually, when you try to set up Anaconda for working with geospatial data, this might be some hassle if you're not aware of the fact that the Anaconda, the default repo, is specifically 2 libraries it comes with, which is MKL and BLAST. They cause a lot of trouble. So what you have to do is you have to remove the default Anaconda repo and you have to install Conda Forge repo. And with that, the libraries that you will use for geospatial analysis. And once you've done this, which is going to take you approximately 2 hours or so, you're good to go. All right, it's showtime. So now let's take a look into how you can actually work with GeoPandas and Shapely. All right, so I'm going to show you. All right, here we go. So we're going to work today with data that is publicly available. And it's been provided by the city of New York. They have a lot of data sets that are consumable either through Kaggle. Some of you guys might know Kaggle as the leading data science community. You will also find some of the data sets on Amazon, so you can just access them from within Amazon. And we are going to specifically work with a data set that shows us the Wi-Fi hotspots, the public Wi-Fi hotspots in New York City. All right, so we're going to walk you through the process of setting up GeoPandas and Shapely, and then performing some very basic analysis and visualization. All right, so first of all, you need to import the libraries. You don't need to memorize everything. So like I said in the beginning, this session is going to be recorded, and this notebook that I'm going to walk you through today is going to be available on GitHub. All right, so first of all, we need to prepare the data. So I already consumed the data from Amazon S3, and it's locally available on my laptop as a CSV file. So first thing that we have to do, we need to convert the CSV file into a so-called pandas data frame. So I'm not going to discuss in detail what pandas data frame is. This is going to be subject to a different webinar, and there's also a lot of content on the subject on the web, just in case you're not familiar with the concept. But in a nutshell, we're going to convert the CSV file, and we're going to just display the first 5 rows so that you can see what type of data is inside this data set. So you're going to see, just walking from left to right, the object ID, which we're not going to use in this case, the borough in New York, the type of Wi-Fi. So is it a free Wi-Fi that you can just use without paying for that service, or is it a paid service? Then the name of the provider, and also the geolocation. So first of all, the address and the longitude and latitude. All right, so once the data set is available as a pandas data frame, we have to do a second conversion. Oh, but before we do that, we just took a glance into that data set, and it holds data on 3,205 Wi-Fi hotspots in New York as of November 2018. All right, so in order to plot the data, to visualize the data, we have to add a tuple of longitude and latitude and apply point, which is a shapely object. So just to translate that in a very simple language, just imagine having a physical map on your wall, and you want to pin to that map, you want to just pin, for example, Post-its, right, with the locations of the different Wi-Fi hotspots. So this is kind of what we're going to do today using GeoPandas and Shapely, okay? So first of all, we have to generate those pins, okay? So these pins are called points, and these are objects, okay? So once, okay, on a sec, I'm just gonna skip through this. Oh no, okay, so what we're gonna do in the first place is create those points, and you can see here, I'm just gonna show it to you. By creating these objects, they're going to be added as a additional column to the data set that we already have, okay? All right, so now that these points are added as a separate column, we need to convert them into a geo data frame. Okay, so once that's done, we can actually plot the data. So as you can see, you just see the points, but you don't see the underlying map yet. So this is something that we have to do as another step. So now that we have the points, we have to add the underlying map. Okay, so first of all, we obviously need a map. And there are different options, there are different maps that are available out there. So for demonstration purposes today, we're going to use OpenStreetMaps. And these are available publicly, so you just grab that URL and you can plot the map. But before we do so, we have to use so-called map projection to transform a spherical object into a two-dimensional surface. So that means the Earth is round, right? And we need data available as a flat data on a map. So you kind of have to make this conversion so that every data point is properly displayed. And you can find information on using map projections on Wikipedia. We just provide a very brief introduction into those here. Okay, so this is where the pieces come together, plotting points onto the OpenStreetMaps. So like I said, we generate a GeoPandas data frame in the first place with the data points, and then we plot those data points onto a map. All right, and obviously you can do this. There's a shortcut, so you can essentially plot the points directly and then add the map to it. So you don't need to go step by step as I did now. But the advantage of doing this is essentially you can be very granular about the type of data that you're using. You can mash up different data sources. So GeoPandas and Shapely give you a lot of options to actually work with data and analyze data. Okay, so now that we have the Wi-Fi hotspots plotted on the map, we want to do some analysis. And obviously, the first thing we want to do, we want to segment those data points. So we're going to segment them by provider, and we're going to give each provider a different color. So we're walking through this process again of creating those points in the first place in different colors, and then we're plotting them onto the map. Here we go. These are the different providers plotted on the map. So you can see that the different providers have their areas. So for example, this area is densely populated by one vendor. This area is densely populated by another vendor. So this is how you can start analyzing the data. And there's obviously a whole lot of other visualization options. So for example, you can use so-called density maps. So we try to be as precise as possible when it comes to the naming conventions. So people typically refer to those as to heat maps, but this is not the correct not the correct term for that. So the correct term is density map, or KDE, which stands for kernel density estimate. So for example, what type of density maps can you create? So you can create this one here, for example. So you can see here the density, the distribution of Wi-Fi hotspots in New York. And you can also do this, for example, using lines, right? So we would, again, once we created this plot, we would add the underlying map to it. So this is how the process works. All right, and you can also use different data types. So you can, for example, use GeoJSON files, and in this case, the data is available in different formats. So we just tried this out with GeoJSON. It's the exact same result, but just we wanted to show you that you can use different formats with GeoPandas and Shapely. And then you can also create so-called Voronoi diagrams, which essentially cluster the data, and this is what it would look like in GeoPandas and Shapely. So this is a very, very brief walkthrough how you can work with geospatial data in Python using GeoPandas and Shapely. Are there any questions so far?
So I might have a question to you, Raphael. Would you share with us your experience of how much time you spent on different steps of this work?
Sure. So specifically when it comes to setting up the data, it's very much straightforward once you understand how to work with pandas and with matplotlibs, which are the underlying libraries. So this analysis, it took me approximately 3 hours once I familiarized myself with the concepts. And you can obviously spend an infinite amount of time, because we're currently looking here at Wi-Fi hotspots, but you could also add other data. So for example, like traffic congestion and other data types. And so that way you can explore your data. And that obviously you can spend, like I said, infinite amount of time on that. But for the basic setup, it's a matter of just a few hours.
All right, thanks.
Sure. All right, are there any other questions from the audience? Are there any questions, Simon? You see anything coming in?
Not yet so far. So
okay. All right, so with that, let me Simon hand over to you, and let's talk about T-Systems Data Science Workstation as an alternative to a setup with Anaconda and Amazon AWS. Okay, so I'm going to switch. I'm going to make you a presenter right now so that you can share your desktop. All right, off you go.
all right, Raphael, can you tell me if you can see my screen?
Yes, I can see that. I can see it. Sure.
All right, perfect. All right, so let me start. Again, at T-Systems, we are a unit which is offering platform as a service and big data platforms and solutions. And let me introduce the Data Science Workstation by telling you how we came up with this idea. So we were visiting a lot of clients and talked there to the data science teams and also their managers, and what we heard everywhere was that they were struggling. They couldn't reach deadlines at time, and the main reason we found out was that data scientists had to do a lot of work which was not connected to their specialties, which is analytics. So they had to do a lot of organizing, they had to administrate, had to set up databases, they had to wait a long time for environments to be provided. They had to work in engineering, so they can do that, but it's not their specialty. So productive analytic work was diminished. And we asked ourselves, what if we could turn that around? That at the end, we have much more productive work and we can reduce significantly the time they have to work for environments and also the workload of engineering. So, and then we thought also, okay, if we offer such a service, what else would be nice for data scientists? We're offering our platform as a service on top of OpenShift. I will come to that later. And this is based on Dockerization in the cloud. And this can offer a lot of different things, and I will briefly go through here. First, we want to do sandboxing. That means we want to try out new ideas quickly, but without destroying anything. And anyone who has like tried out to set up new environments on his own local desktop knows that sometimes things can go wrong. So we want to do that in a safe environment, and we want to do it quickly. Then second, if we want to produce a new idea, if we want to productionalize it, we have usually to start with a proof of concept. And this proof of concept, we want to develop fast and easy and agile. And this can be done easily in the cloud. So I have resources in the cloud. They are there by just a click very often. And I can work with Dockers in a very agile way. Third, training. Everyone who's working in data science has recognized that in the last 3 to 4 years, a lot of frameworks came up. The pace just accelerated, and also known frameworks bring up new versions which change considerably, sometimes the framework at whole. So training our team is usually something we have to focus more often in the future. And this is also possible by a Dockerization in the cloud, because I can just provide the same environment. I have resources for everyone, and we can start very quickly by, for example, doing a peer coaching there. Fourth, locality. I think this is very obvious to anyone. So downloading the data to my desktop and then making an analysis, that's not very efficient. So I want to build up my analysis and then send it over to the data so it can execute, for example, then in the cloud where the data is stored. Then ad hoc analysis. This is just a very cool feature because, for example, imagine you are preparing a meeting, you're flying over, you're sitting and waiting for your flight, and you just want to check some more numbers. You get your iPad and you can just access the data via your browser and make some quick analyses. Last but not least, if we are going into production with a new, let's say, model or application using analytics, something that becomes important is continuous integration and continuous deployment. And so this is possible very easily when we focus on microservices, which is based on Dockerization. And so we can continuously deploy something new versions. Netflix, for example, does that 14 times a day in average. So they have a very nice pipeline there. And if you can like separate your application into smaller modules, different teams can work on these modules. And this is possible by Dockerization in the cloud. So let me show you how everything is set up. So first, there's an infrastructure layer. which we offer. And this is based on like 3 clouds. This is the Open Telecom Cloud, of course, then Microsoft Azure, where we have like 1.5, I think, to 2 years of experience with. So we do that as a standard. We are moving now over to AWS, so give us a couple of months. And this is also a standard. Who wants to have that quickly can order this as a solution, and we work this out for him individually. And then if you have the resources, you need a kind of orchestration that can orchestrate these resources and put certain resources to certain applications. This is done by Kubernetes. And in case of our platform as a service, we have to mention it in relation to Red Hat OpenShift, which our PaaS is based on, because Red Hat OpenShift uses implicitly Kubernetes to orchestrate their Docker containers on the different infrastructures. So we have used Red Hat OpenShift and Docker technology and Kubernetes like for 4 to 5 years. We have a lot of experience with this. And we also made Red Hat OpenShift enterprise ready. So we added some nice features and also a consumption portal where you can see how much you consume. Then on top of this platform, we offer the T-Systems Data Science Workstation. So the Data Science Workstation is fully based on microservices, this very innovative technology. And we will see on the next slide how the Data Science Workstation is set up. It is based on Jupyter Hub. So you will have Jupyter notebooks, and right now we are also working on implementing Jupyter Lab, which is just the next generation of Jupyter notebooks. You can Google it. It just looks very fancy. It has some more features. It's very nice to work with. And there are a couple of so-called kernels. And kernels define languages. We have implemented a couple of kernels like Python 3 or Octave, Bash, and so on. Then it comes with frameworks like TensorFlow, Keras, Plotly, H2O, so you can make visualization of data, you can make machine learning, artificial intelligence, and it also has some additional features, like, for example, a tensor board feature, so you can start out of your data science workstation a tensor board to just inspect your TensorFlow models and their training. So we started with our platform as a service by also offering some base images, which you probably know when you see that, like MySQL, MariaDB, PostgreSQL, Nginx, and so on. And all these images can be used freely on our platform. So you just pay for the resources you use. And the same holds true for the Data Science Workstation. So you buy actually your platform with your resources, and you just pay the resources you use and not actually the Data Science Workstation image. That is very cool. And in addition, as we are also offering big data for our customers, we developed a small big data environment based on Hadoop, Hue, Spark, and so on, which runs on our platform on OpenShift and is based on Docker. So you can try out some analysis on big data and try out some applications, for example, with Spark, and then you can set it up on your production cluster, which is then probably on bare metal. But this is also free, so you have a free Hadoop system on there. You just pay for the resources you use with it, and you can make yourself familiar with Hadoop systems. So let me tell you how the Data Science Workstation actually works. So you can access the workstation via your browser. So you get a link, and via HTTPS you can access the pod, this is a kind of container on the OpenShift Jupyter Hub. And this pod is just responsible for authenticating users. And if it authenticates a user, it locks it into the Jupyter Hub database pod and spawns a new Jupyter Notebook pod, which you see just down here. And this Jupyter Notebook is where you actually work on your analyses. And you see in blue a persistent volume, which is attached to every Jupyter Notebook pod. That means you can store on this persistent volume all your data. You can store on it your analyses. You can also set up your own environment there. So you can store additional packages which only you are using. And if you're done with your analyses for the day, you can just kill your Jupyter Notebook pod, but your data and analyses are just stored safely on the persistent volume. So last but not least, a big reference of this data science workstation is See Here Request. Some people might know it. It's from Deutsche Telekom Game for Good initiative. And they developed a mobile app and collected in the game they offered there thousands of data for dementia. It's the largest data set right now for research in dementia, neuroscience, and psychology. It holds over 4 million users. And the scientists have to log in from everywhere in the world safely. And this is done via our T-Systems Data Science Workstation via the browser. And then they have access to a Cloudera bare metal cluster and can use Apache Spark on this huge data set to work efficiently on the big data. And just that you get also a picture, an image of how it looks like, I would like shortly in 2-3 minutes show you how this all works. So we have here our browser. We can log in here to the back end. So we log in here to OpenShift, all right? And everything is organized in there in projects. Here I have my project with, for example, the Hadoop environment. And we scroll down and see here, this is actually the data science workstation. And you see there's running a pod, which is this Jupyter Hub, which is responsible for the authentication of users. We see here the database. And then we see here for every user, his own pod. So every environment is independent of other users' environments. And we see here a link. Okay, and this link gives your users a direct access to their database, to the data science workstation. And if you log in, this is what you actually see there. Okay, I have a couple of notebooks here, and these notebooks, I can open them. All right. And this one is, for example, on e-commerce data. All right, Olist, which is a Brazil company similar to Amazon. And then I can just execute my code in the cloud. And here, for example, I can connect to the existing Spark cluster and do my big data analysis. So, but we're going to talk about this, I think, in upcoming webinars in next year. So I'm finished, Raphael, and I think we can open up the Q&A part.
Sure, thank you so much. So I see there are no questions so far from the audience. So let's maybe wrap up this session. So we are planning, so a few things that we would like to share with the audience right now. So first of all, we are very likely going to host this session in German for those of you guys who feel more comfortable consuming this type of content in your native language. And we are also going to host sessions in which we are going to discuss in detail how you can actually work with geospatial data utilizing Python in the environment that Simon just described. So Simon, any additions on from you, Simon? Is there anything you would like to share with the audience?
Not really. So I was expecting some questions. Of course, we can talk a little about the environment, or we can talk about what kind of features we have implemented in the data science workstation. So whatever is interesting to the audience.
Yeah, maybe you can. Yeah, maybe we can. We still have some time, so maybe we can spend another 5 minutes or so. Can you maybe dive a little bit deeper into the infrastructure that is at use and the context of data science workstation, T-Systems data science workstation?
Yeah, sure. So let me just switch back to so if we talk about the setup on our platform, the infrastructure that can be used are of course also, for example, GPUs. All right, so the Kubernetes cluster, which is like orchestrating all the resources which are available. All right. That can also include GPUs or different other devices. Okay, so if I have to make some certain computations which are computing intensive, all right, I can, for example, use GPUs on it. Or if I need hard disks with very fast access, all right, for doing some data analysis, I can also order some storage which offers this, and I can put it into my Kubernetes, register it with it, and then I can use it on the platform. So that's a very nice feature, okay, if I imagine the work of data scientists, okay. And we're going to see that this will be done more and more in the future. So using GPUs is something which will come up. And also, to be clear, we cannot use only the big data clusters which are on the platform itself. We can also use any big data cluster actually anywhere. So I imagine, for example, in the automotive industry, they will have a lot of data, also geo data, which is stored in big data clusters. Okay, and so if I want to make analysis in the way you showed here, Raphael, you can do that by connecting to the big data cluster where these geodata is stored, and then make your analyses on the cluster using the cluster resources instead of your own ones. Yes, and just to follow up, we see here a couple of frameworks and a couple of languages which are implemented, but you can imagine actually that we can implement any kind of framework, and we can do that as a kind of solution for customers. And the main thing to think about is that you want to spend your resources, which you pay a lot of money. This is what data scientists are right now. You want them really to work on what they can do best, and that's making analyses and producing models, right? And so you want to reduce the part of engineering as far as possible. This is something we offer. We set up everything, and you get on and make your analyses.
Super. Thank you so much. Thank you so much, Simon. So for those of you guys who joined us a little bit later, this session is going to be recorded, and we're going to dive deeper in January, February next year, specifically into working with geospatial data on data science workstation. So Simon, I think we're good to go. And since there are no further questions, or there are no questions from the audience actually, so we can wrap things up and hopefully see you next time in January, right?
Yeah, thank you very much for.
All right. Thank you. Bye bye. See you next year. Have a good holiday.